Hello, good morning. This is Nas from NB Network Lessons. Hope everyone's doing okay. Date today is August 2, 2024. Thank you for joining. Actually, sorry for the delay. I've been out for a week. I was on vacation in Iceland, the most beautiful place on earth. I would even say heaven on earth, especially the north side, the mountains, the sceneries, the glaciers, the geysers, where there is water underneath the earth, boiled up by lava, and it comes out of the earth in form of a spray every 5 minutes. Breathtaking, breathtaking. Also, the waterfalls were beautiful. So, if you can, definitely put that on your to-do list is to visit Iceland. But having said that, let's go ahead and dive into directional derivative. I've been talking about directional derivative for last three lectures, and basically, this is part of calculus 3, advanced calculus, where you have to find a directional derivative. In other words, traditionally what we've been finding is, we've been finding derivative in x-axis, we've been finding derivative in y-axis and z-axis. Okay, however, when you go out in the real world, you have to find a derivative in any direction, not just x, y, or z, any direction. And that is what directional derivative is. So once you become NASA engineer, or you become a scientist, or you become mechanical engineer, civil engineer, you will use this. I promise you. So this is what I was talking about. Like, if let's say you have something like this, okay? This is your z, this is your x, and this is your y. Okay, traditionally what we've been doing is that we've been finding derivative along x-axis, derivative along z-axis, derivative along y-axis. No, in this case, you pick arbitrarily, you pick a direction and find derivative across this, find a derivative along this. You have a function, something like this. Okay, I want you to find derivative along this direction. So that's what we are talking about, directional derivative. Okay, well, let's solve a problem. And if you do need a refresher, you can go into my collections and you can find a lesson on directional derivative under Calculus 3 folder. You will see some. But anyway, the problem we have is function of x, y is equal to E4y. Now, have you noticed something in this function? There is no variation of x. The only variation over here is with respect to y, but there is no variation with respect to x. So, what we have been asked is to find the directional derivative at point 1 over half and 1 over 4. Okay, and the vector we are given is this right here. I denote this by a bar as a vector, and then every vector has a x component and a y component. So this vector is 4. I put a hat on it, which denotes a vector I, which is in x direction. Okay. Now remember one thing, the vectors have x component as well as a y component. So when you throw a ball like in a parabola shape up in the air, okay, it has an x component and it has a y component also. Okay, so if the weight of y is more than x, okay, then the ball will kind of go towards the y direction, high. So keep that in mind, the weight, relationship of weight of x and y. If the weight with x in a vector is more, it's going to go along the x-axis more. Might not be just parallel to x-axis, but it's going to go along x-axis. So in this particular case, I don't see a y component. We just have an x component. So first thing what we need to do is we need to make sure that it is a unit vector. That is the condition, mandatory condition, that in order to find directional derivative, you have to make sure that your vector is a length of the vector is a unit vector. So how do we do that? What we do is that we find the length of the vector and we denote it like this. We have two bars on the left hand side. Then we put the a bar. This is known as length of the vector. I'll write it down also. Length of a vector is equal to, all you got to do is take the weight, which is this right here, 4, okay, and basically square it under root, okay. So this is how you find the length of the vector. So then this is obviously just going to be 4. So now we know that the length of this vector is not a unit vector. It's not 1. So we got to do some manipulation, do some math. How do we make this a unit vector? Let's see how. What we do is we take the vector itself, not the unit vector, take the vector A, okay, and what we do is we divide it by the length of the vector, which we just calculated. So jot down this formula because you're going to see this in exam. And I will circle that with red. And this is basically how to make a unit vector. Okay. So now let's go ahead and plug in the values. What is the value of A? I'm talking about this right here. So this is basically, let me write this down again, vector divided by length. So that is equal to 4 hat I, this is my vector, divided by length, which I just calculated. So this 4 and 4 cancel. So then what we do is that we have I or hat is equal to A. Okay. So then we can say our A1 is equal to just 1. So now we made it a unit vector. Okay. Now let's go ahead and calculate the partial derivative. But before I move further, in general, remember that a vector is represented by A hat is equal to A1 I hat plus A2 J hat. Okay. So that's how this is basically the X component and this is basically the Y component. Okay. All right. And let's go ahead and look at it further. Let's go ahead and find the directional partial. Hello, this is Naz from NB Network Lessons. Date today is 8/2/24. This is the continuation of my lecture in which I was not able to finish this problem due to the time constraint. However, I'm going to show you and I'm going to solve this problem. So basically, this was the problem, function of x, y, e raised to power 4y. And we were given points half and 1/4. That is where we need to calculate the directional derivative. So this right here is the unit vector we are given. We need to, first thing is we need to verify if it's a unit vector. How do we verify unit vector? What we do is that we take the length of the vector, and this is how we denote the length of the vector. 2 bars in between a vector, then 2 bars again, equal to, what you do is that you take square of the weight and square root. So then it comes out 4. Okay. Well, that is not 1. So it's not a unit vector. So we can't really proceed finding directional derivative, because the condition is that the length of the vector should be 1. So now what we do is that the way we calculate is the way we do it. What we do is that we take the vector itself and divide it by length, okay, to make it a unit vector. So what is the A, the vector which was given to us right here, 4I with a hat, divided by the length, which is 4, right? We calculated that. And then I hat is equal to A hat. So then we know A1, the weight A1, because in general, a vector has two components. A1I with a hat, which is the X component, A2J with the hat, which is the Y component. Always remember that. Now what we got to do is we got to take the partial derivative. Okay. So that is where I left last time, by the way. So now what we do is that we say directional derivative at point A, f at point half and 1 over 4 is equal to, we take the derivative with respect to x only. At point half 1 4, we multiply with the weight on the x side times a1, plus we take the derivative with respect to y. So function of y at point half 1 over 4, and we multiply that with the weight a2. I explained you the weight, the concept of weight, x component associated with vector and y component. You throw a ball like this in the air, okay? When you throw the ball in air, it has an x component, it has a y component. If the y component is heavy, more weight, the ball is going to go up more, right? If the x component, the weight is heavy, then it's going to kind of like not really parallel, but go like this, not towards more x-axis, but more like towards not towards more y-axis, but towards x-axis. So just wanted to mention that. Now what we got to do is we can plug in these values, okay, in the on the derivative of this function with respect to x. Well, there is no x in here. Do you see an x in here? So then this right here is going to be basically 0 multiplied by the weight. What is the weight? A1 weight we calculated. This right here. Weight is A1 weight we calculated was, let's see, 4. Sorry. A1 weight we calculated was 1. Okay. We just did this right here. That's the weight with respect to x. Plus, what we do is that we take the derivative of this function with respect to y. So e raised to power 4y. So we write e 4y, and then we multiply it with the derivative of what's inside, which is 4. Okay. Now plug in the value of y in here. 0 times 1 is 0, plus e raised to power 4. What is y? Y is 1 over 4 multiplied by 1 over 4 times 4. This 4 cancels, okay? And then what you have is, we have to multiply this by the weight. Now let me ask you this. In this particular vector, you have x component. Is there a y component? I don't see a y component. So this is going to be multiplied by 0. All right. So let me make it clear one more time. Let me erase this so you can understand this better. Okay. Here's what I'm saying. What I'm saying is that you take the derivative of this respect to x. When you do that, there is no x in here. There is no x variation. So this is a constant. All right. So this vector right here is, there is basically, since there is no x in this, so then what is going to be my derivative of this? The derivative right here is going to be 0. Okay. And then you multiply that by the weight, which is 1 right here, plus you take the derivative with respect to y. So with respect to y, when you do E4y, write it just like this, multiply this by 4, what's inside, remember the chain rule, take the derivative of the big picture, then go inside and take the derivative of the smaller picture, times the weight. Now let me ask you this, is there a y component? Okay, because a vector has a1, a2, there is a2, there is none, so this is multiplied by 0. Okay, so then this thing is 0 plus 0. That is it. That's the answer. So what does that mean? What it means is that, let's say you go into a mountainous area like Iceland, and you see mountains up and down, and you're a hiker. You get on the mountain, you look straight. Okay, you look straight in the direction in which you have find directional derivative, and you don't see any hill. All you see is everything straight. That's exactly what it is. No slope, derivative is going to be 0. Thank you so much for watching. Till next time, take care of yourself.